A double pipe parallel flow heat exchanger is to heat water. Cp is 4180 joule per kg degree Celsius from 25 degrees Celsius to 60 degrees Celsius at a rate of 0.2 kg per second. The heating is to be accomplished by geothermal water. Cp means 4310 joule per kilogram degree Celsius, available at 140 degrees Celsius at a mass flow rate of 0.3 kilogram per second. The inner tube is thin walled and has a diameter of 0.8 centimeter. If the overall heat transfer coefficient of the heat exchanger is 550 watt per meter square degree Celsius, we have to determine the length of the heat exchanger required to achieve the desired heating. So there is a figure from this given information of this particular problem. Water 25 degrees Celsius, 60 degrees Celsius, here the temperature is 140 degrees Celsius. That is the solution of this problem. The rate of heat transfer in the heat exchanger is Q dot is equal to m dot Cp into T out minus T in for water. We have all this value. So m dot is 0.2 kilogram per second. Cp means 4.18 kilojoule per kg degree Celsius. T out minus T in means 60 degrees Celsius minus 25 degrees Celsius. So the value of Q dot is 29.26 kilowatt. Then the outlet temperature of the geothermal water is determined from this equation. Q dot is equal to m dot Cp T in minus T out for geothermal water. So T out means T in minus Q dot by m dot Cp. So we have all this value. T in means 140 degrees Celsius minus Q dot is 29.26 kilowatt. M dot is 0.3 kilojoule per second and Cp means 4.31 kilojoule per kg degree Celsius. So the value of T out is 117.4 degrees Celsius. So now we have four values, and from this we can determine the logarithmic mean temperature difference for hot and cold fluid. So del T1 is equal to Th in minus Tc in, that means 140 degrees Celsius minus 25 degrees Celsius, that means 115 degrees Celsius. And del T2 is equal to Th out minus Tc out is equal to 117.4 degrees Celsius minus 60 degrees Celsius. So del T1 is equal to 115 degrees Celsius and del T2 is equal to 57.4 degrees Celsius. And del T Lm is equal to del T1 minus del T2 ln del T by del T2, that means 115 minus 57.4 divided by ln 115 divided by 57.4. So the value of del T Lm or log mean temperature difference is 82.9 degrees Celsius. The surface area of the heat exchanger is determined from this equation. Q dot is equal to UAS del T Lm. So AS means Q dot divided by U del T Lm. The value of Q dot is 29.26 kilowatt. The value of U is 0.55 kilowatt per meter square and del T Lm is 82.9 degrees Celsius. So Q dot is 0.642 meter square. Then the length of the tube required becomes the surface area. AS is equal to pi dl. Here L is unknown, so L is equal to AS divided by pi d. The value of AS is 0.642 pi, that means 3.1416, and d is equal to 0.008 meter. So the value of L is 25.5 meter. So this is the solution of this particular problem. The heat exchanger design procedure using the LMTD. With the LMTD method, the task is to select a heat exchanger that will meet the prescribed heat transfer requirements. The procedure to be followed by the selection process is: number 1, select the type of heat exchanger suitable for the application. Number 2, determine any unknown inlet or outlet temperature and the heat transfer rate using an energy balance. Number 3, calculate the log mean temperature difference del T Lm and the correction factor F if necessary. Number 4, obtain or select or calculate the value of the overall heat transfer coefficient U. Number 5, calculate the heat transfer surface area AS needed to meet requirements.